students, so now we are going to solve a numerical, that is to find out the Fourier expansion of f of x equal to mod cos x in minus pi to pi. So guys, be careful because the function is inside the mod cos x. You must be thinking that it's very simple, we can use cos x directly, then you are making a mistake, because we can find out the integration of cos x but not of mod cos x. So you have to remove that mod. Okay, so let's try to remove that mod from cos x. So guys, before doing this, let's check whether this is even function or odd function. Now why I'm asking you? Because the range is negative pi to pi. So always remember guys, whenever range is minus a to a, then always check for even and odd, because it reduces your work. If you get function as odd, then you don't have to find out a naught and an. You can get directly bn, because a naught and an is 0 if f of x is odd, and if f of x is even, bn is 0. So if you are not understanding these cases, then you have to go back to my video where I had explained the concept of even and odd function is in negative pi to pi. So first of all, let's check if mod of cos x is even or odd. So guys, let's start. So here I'll say, let's find out f of minus x. So f of minus x is mod of cos of minus x, and guys, it is nothing but mod of cos x. So here I can say that mod of cos x is f of x, and therefore we are getting f of minus x equal to f of x, and whenever we get f of minus x as f of x, we say the given function is even function. So here I'll say therefore f of x is an even function. So guys, now for even function we have derived the formula. So whenever f of x is even function, we know that the value of a naught is this and value of an is this, and we get bn as 0. So if you see this a naught and an, the range is from 0 to pi in both the cases. So since we have cos x inside the mod, here we are gonna use the concept of the modulus function. Now for that, let's understand how modulus function operates. So guys, you must be knowing that mod makes the negative number as positive, or it keeps positive number as positive. So for example, let's say if I have value x as minus 5, so if I keep it inside the mod, then mod of negative 5 will be always 5. So guys, now my question to all of you, what if I remove mod from x? So whenever we remove mod from x, then that time that x will take its original value. So it means if I remove mod from here, then x will have two values, that is x and negative x. Now when it will have value as x? If x is greater than 0. And when it will have value as negative x? If x is less than 0. So if, for example, if I have mod of minus 5, correct? Now if I am planning to remove that mod, then the original value is minus 5. So it means we'll get answer as minus 5. Because when I said mod of minus 5, that time this value minus 5 is x, and this x is less than 0. So if it is originally less than 0, then after removing that mod, it will be a negative value. So guys, the same concept of modulus function, this is called as modulus function, I am going to use for mod of cos x. So guys, you all must be knowing that cos x has different values in different quadrants. So here I'll draw it for you. So in the first quadrant, all angles are positive. In the second quadrant, sine and cosec are positive. Third, tan and cot are positive, and in the fourth, cos and sec are positive. Now in our case, we have range from 0 to pi. Now even though it is negative pi to pi, as we are going to use the formula of even function, our range will be from 0 to pi. So let's say here we have 0, here we have pi. Now if you see the value of cos x originally without mod, then in the first quadrant till 0 to pi by 2 it will give you value as positive, but in the second quadrant that will become negative originally, because in the second quadrant only sine and cosec are positive. So therefore I can say that this cos will have two value, cos x and negative cos x. This value when x is between 0 to pi by 2, and this value when x is between pi by 2 to pi. So guys, here it means that cos x will have two values. Now if you observe here, then I have removed the mod, and due to that cos will take its original value. So originally it will be negative in second quadrant and positive in the first quadrant, but due to cos it becomes positive. So I think like you understood it in the reverse aspect. So in the school days what we were having is, they used to give us the negative number inside the mod and they used to ask us the answer. So we used to say it is 5. So we used to apply the mod on negative numbers. Now here we are doing reverse case, that the number is written inside the mod and if you want to remove the mod, we are not applying the mod. So after removing the mod, the value which is inside the mod will take its original form. So the original form of cos is negative in second quadrant and positive in the first quadrant. So guys, these are the two values of cos that we got, and we will call this as f of x because the mod of cos x is also our f of x, and we are going to use this to f of x to find the Fourier expansion. So let's start. So here I'll start with a naught. So what is the formula of a naught? A naught is given by 1 by pi integration 0 to pi f of x dx. Now guys, this range 0 to pi is divided into two parts, 0 to pi by 2 and pi by 2 to pi. In first range f of x is cos x, in second range it is negative cos x. So let's write it down. So 1 by pi as it is, then integration from 0 to pi by 2 first range, where f of x is cos x dx, plus second range is pi by 2 to pi, value is negative cos x dx. Now let's evaluate the integration. So 1 by pi as it is, integration of cos x is sin x from 0 to pi upon 2, plus minus n outside, integration of cos x is sin x, again pi by 2 to pi. Let's evaluate this. So 1 by pi as it is, sine of pi by 2 is 1, minus sine of 0 is 0, middle sign negative, sine of pi is 0, minus sine of pi by 2 is 1. So minus and minus will be plus 1 and 1 plus 1 2. So guys, therefore the value of a naught, here I'll write down for you, therefore a naught is equal to 2 by pi. So here I got a naught. Now let's find out the value of an. So the formula for finding the an is nothing but 2 by pi integration 0 to pi f of x cos of nx dx. Now guys, let's find it out. So 2 by pi as it is, this range is divided into two parts. First is 0 to pi upon 2, in which f of x is cos x, so cos x into cos of nx dx, plus the second range is pi by 2 to pi, in which f of x is negative cos x into cos of nx dx. Now here 2 by pi as it is. Now here I can apply a formula of cos A into cos B. So by that formula we will get answer as 1 upon 2 in bracket cos of A plus B. So that is cos of x plus nx, which is 1 plus n into x, plus cos of a minus b, so x minus nx, that is cos of 1 minus n into x. So guys, I am sure you understood this formula. Next one, plus minus will be negative, pi by 2 to pi, again half, and here we will get cos of 1 plus n into x plus cos of 1 minus n into x dx. Now from the first and second term I can take 1 by 2 common and outside, so that 1 by 2 will be cancelled with this 2 and we will get only 1 upon pi. Now let's evaluate the integration. So here we will get the first value as integration of cos, that is sine of 1 plus n into x upon 1 plus n, plus sine of 1 minus n into x upon 1 minus n, and that is from 0 to pi upon 2. Middle sign minus. Now again integration of this cos, which is sine 1 plus n into x upon 1 plus n, plus sine of 1 minus n into x upon 1 minus n from pi by 2 to pi. Now guys, let's put upper and lower limit and evaluate the function. So it is equal to 1 by pi, and here when we'll put this pi by 2, here we'll get sine of 1 plus n pi by 2 upon 1 plus n. So here I'll write it down, sine of 1 plus n pi by 2 upon 1 plus n. Next, plus, if I put here, I'll get sine of 1 minus n into pi by 2 upon 1 minus n. So this is what about the upper limit. If I put lower limit is 0, sine of 0 0, sine of 0 0, no need to write. Then sine is negative, so I'll put a bracket over here, sine is negative. Now let's start with the second term. So if I put pi here, sine of pi, that is sine 1 plus n pi is 0, sine 1 minus n pi is 0, no need to write. So straightforward 0, minus, if I put pi by 2, again we will get sine of 1 plus n pi by 2 upon 1 plus n, plus, so here we will get sine of 1 minus n pi by 2 upon 1 minus n. So guys, this is end of these two brackets and end of curly bracket. Now here we got the terms like sine of 1 plus n pi by 2 and sine 1 minus n pi by 2. So let's evaluate it first. So here I'll say sine of, this will become pi by 2, because 1 into pi by 2 is pi by 2, plus minus n pi by 2. So this is nothing but sine of pi by 2 plus theta, or sine of pi by 2 minus theta. In both the cases it is cos theta, so I'll say it is cos of n pi by 2. And guys, I am gonna substitute this value everywhere at 4 places. So here we will get 1 by pi, first value, that is cos of n pi by 2 upon 1 plus n, plus cos of n pi by 2 upon 1 minus n. Next, minus and minus is gonna be plus cos of n pi by 2 upon 1 plus n, and this one plus cos n pi by 2 upon 1 minus n. Then the first and third term is same, or I can take cos n pi by 2 outside from all the terms. So cos of n pi by 2 outside upon pi. In the bracket we will get this plus this, that is 2 times 1 upon 1 plus n plus 2 times 1 upon 1 minus n. I can take 2 also outside. So here we will get 2 times cos of n pi by 2 upon pi, and this will become 1 minus n plus 1 plus n upon 1 minus n square. Now guys, here we can cancel this positive and negative n, and we will get 1 plus 1 2. So this will become, here I'll write down an will be 2 into 2, that is 4. So 4 by pi cos of n pi by 2 upon 1 minus n square. So guys, here we got an. But guys, be careful, because the value of an that we got is not going to help us out, because if you see the Fourier series, we have summation n equal to 1 to infinity an cos nx. Now guys, there n starts from 1. So when we put n equal to 1 here, we will get 1 minus 1 0, and some finite value upon 0 is infinity. So we will get answer as infinity. And if we get one term as infinity, whole value is infinity. And therefore we'll get Fourier expansion as infinity, which is not possible. We want the finite expansion of the given function. So therefore this answer is valid for all the values of n except at n equal to 1. So here I'll say except at n equal to 1. So therefore guys, at n equal to 1 we have to find out the value of an again. So how to get that value? So it's simple. Here we had started. So in this we will put n as 1, because at n equal to 1 we are getting answer as infinity. So let's find out the finite value of a1 separately. So if I put n here 1, so I'll get a1. This will be cos x into cos x cos square x. This will be cos x into cos x again cos square x. So we'll find out the value again. So here I'll say therefore put n equal to 1 in an, and we will get a1 equal to 2 by pi, the formula, that is 0 to pi by 2. This is cos square x dx plus integration from pi by 2 to pi, and this will be negative cos square x dx. Now let's evaluate this integration. So this is 2 by pi. Now we cannot get value of cos square x directly, so hence we have to convert that using the formula of trigonometry. So guys, integration 0 to pi by 2 as it is. The formula for cos square x is 1 plus cos of 2x upon 2, and from this term we can get the integration. Similarly, plus and minus pi by 2 to pi, we have again the same term, which is 1 plus cos of 2x upon 2 into dx. Now from both the terms I can take 1 upon 2 common, will be cancelled with this 2, and we will get 1 upon pi. Now guys, integration of 1 is x plus integration of cos 2x is sine of 2x upon 2 from 0 to pi upon 2 minus same integration x plus sine of 2x upon 2 from pi by 2 to pi. Now let's put upper and lower limit. So we will get 1 by pi, here pi by 2 first term, plus when I put pi by 2 here, this 2 and 2 will be cancelled, will get sine pi, and guys sine pi is 0. Similarly, if you put lower limit as 0, you will get 0 here, and sine 0 again 0, so I will not write that term. Middle sign minus. If you put pi, you will get pi here, plus sine 2 pi, again it is 0. Next, so I'll write this in the bracket, minus lower limit is pi by 2, so pi by 2 plus Here pi by 2 cancel, sin pi is 0. So this is lower limit, upper limit minus lower limit. So guys, let's simplify this. So here we will get 1 by pi in the bracket, pi upon 2. Due to this negative sign, we'll get minus pi, negative negative, positive pi upon 2. So pi by 2 and pi by 2, addition of that is pi, and minus pi is 0. So we will get value of a1 as 0. So guys, we got a1 as 0. Now let's find out bn. So we know that it's very simple, bn is equal to 0 since the given function f of x is even. So now let's write down the Fourier series and let's put all the values. So therefore here we'll say the Fourier series for even function f of x is given by f of x equal to a naught plus summation n equals to 1 to infinity an cos of nx, and there won't be any bn term. So here I'll say since bn is 0. Now let's put the values of a naught and an that we got here. So guys, here in this sum we got a naught as 2 by pi. Here I'll show you. So this is the value. I'll put this value here. So this will become 2 upon pi. Now an, we got value like, so for an we got this value. I'll put this value in an. So now this value of an is not valid for n equal to 1, and hence we got value of a1. But again the value of a1 we got as 0. So what we'll do is we will divide this range into two parts, that is plus a1 cos x by putting n equal to 1, and that value of an is acceptable for all the values of n, hence we'll write down summation n from 2 to infinity. So I have separated first value because for first value it was giving infinity. So an cos of nx. So now I'll put value of a1 separately. So guys, we got value of a1 as 0. So we'll say 2 by pi, this value 0, and here we will get plus summation n from 2 to infinity. N is 4 upon pi cos of n pi upon 2 upon 1 minus n square into this cos of nx as it is. So you can keep this answer as it is. So guys, you can keep this answer as it is, or if you want you can put different values of n starting from 2 and you can evaluate the terms. So guys, this is what the Fourier expansion of mod of cos x in minus pi to pi. So I'm sure that you understood this problem, this numerical, and you must have understood how to apply the concept of modulus function when you get a function inside the mod. Thank you very much.